Submarine canyons are larger than the Grand Canyon, hidden giants beneath the waves. When people think of monumental canyons, images of the Grand Canyon often come to mind, its vast expanse carved by the Colorado River and awe-inspiring in scale. However, some of Earth's most impressive canyons are not on land but hidden beneath the ocean. Submarine canyons such as the Monterey Canyon off the coast of California are deeper, longer, and older than their terrestrial counterparts. These underwater marvels, carved over millions of years by powerful underwater currents, remain some of the least explored yet most fascinating geological features on the planet. What are submarine canyons? Submarine canyons are steep-sided valleys cut into the seafloor, typically starting near the continental shelf and extending into the deep ocean. These underwater landforms can rival or exceed the dimensions of terrestrial canyons, with depths of several kilometers in lengths, stretching hundreds of kilometers. Key features of submarine canyons. Depth. Some submarine canyons reach depths exceeding 10,000 feet, 3,000 meters, far surpassing the Grand Canyon's maximum depth of about 6,000 feet, 1,800 meters. Length. These canyons can extend for hundreds of kilometers, connecting shallow coastal regions to the deep ocean basins. Location. Found on the continental margins, they often start at river mouths or along tectonic boundaries. Monterey Canyon, an underwater giant. One of the most famous submarine canyons is the Monterey Canyon, located off the coast of Central California. This canyon begins at Moss Landing in Monterey Bay and stretches over 470 kilometers into the Pacific Ocean, with depths reaching over 3,600 meters, 12,000 feet. Comparisons to the Grand Canyon. Depth. The Monterey Canyon is deeper than the Grand Canyon at its lowest point. Length. While the Grand Canyon spans 446 kilometers, Monterey Canyon's undersea expanse extends even further. Carving forces. Unlike the Grand Canyon, which was shaped by the erosive power of the Colorado River, Monterey Canyon was carved by powerful underwater currents known as turbidity currents. Formation of submarine canyons. Submarine canyons are carved by processes unique to the underwater environment. Unlike rivers, which cut through rock and sediment on land, these canyons are formed by the combined forces of turbidity currents, underwater landslides, and geological activity. 1. Turbidity currents. Turbidity currents are dense flows of sediment-laden water that rush down the continental slope, driven by gravity. These currents act like underwater avalanches, scouring the seafloor and carving deep channels into the sediment and bedrock. Trigger events. Earthquakes, storms, or floods can initiate turbidity currents, sending vast amounts of sediment cascading into the deep ocean. Erosive power. These currents can move at speeds exceeding 50 kilometers per hour, 31 miles per hour, carrying enormous amounts of sediment that grind and deepen the canyon walls. 2. Geological activity. Submarine canyons often form in tectonically active regions where the movement of Earth's plates creates fractures and uplifts in the seafloor. These geological features guide sediment flows and amplify erosive processes. 3. River contributions. Some submarine canyons originate at the mouths of major rivers, where sediment from terrestrial sources flows into the ocean and continues carving the canyon underwater. Examples of remarkable submarine canyons. While Monterey Canyon is one of the most studied submarine canyons, it is just one example of these impressive undersea features. Other notable submarine canyons include 1. Jemtchug Canyon, Bering Sea. The Jemtchug Canyon in the Bering Sea is the largest known submarine canyon in the world. It plunges to depths of over 2.6 kilometers and spans a width of 100 kilometers, dwarfing any terrestrial canyon in scale. 2. Amazon Canyon, Atlantic Ocean. Located at the mouth of the Amazon River, this canyon extends for about 750 kilometers into the Atlantic Ocean. It is a prime example of a submarine canyon formed by massive sediment deposits from a major river. 3. Congo Canyon, Atlantic Ocean. The Congo Canyon, found off the west coast of Africa, is one of the deepest submarine canyons, reaching depths of over 4,800 meters. It channels sediment from the Congo River far into the deep ocean. The importance of submarine canyons. Submarine canyons are not just geological curiosities, they play vital roles in Earth's ecosystems and geological processes. 1. Sediment transport. These canyons act as conduits for sediment, transporting materials from the continental shelf to the deep ocean. This process helps shape the seafloor and influences the distribution of nutrients in marine ecosystems. 2. Biodiversity hotspots. Submarine canyons are often teeming with life. Their steep walls and unique currents create diverse habitats for a wide range of species, from corals and sponges to fish and crustaceans. The nutrient-rich waters flowing through these canyons support vibrant ecosystems, including commercially important fisheries. 3. Carbon storage. The sediment transported through submarine canyons plays a role in the ocean's carbon cycle. Organic material buried in the deep sea through these processes helps sequester carbon, regulating Earth's climate over long timescales. 4. Geological insights. Submarine canyons provide valuable information about Earth's geological history. By studying the sediments deposited in these canyons, scientists can reconstruct past climates, ocean currents, and tectonic events. Challenges of studying submarine canyons. Despite their significance, submarine canyons remain one of the least explored features on Earth. Their remote locations and extreme depths make studying them a logistical and technological challenge. 1. Technological limitations. Exploring submarine canyons requires advanced technologies such as remotely operated vehicles, ROVs, autonomous underwater vehicles, AUVs, and sonar mapping systems. These tools are expensive and often limited in availability. 2. Data gaps. Many submarine canyons are poorly mapped, leaving significant gaps in our understanding of their distribution, formation, and ecological roles. 3. Environmental risks. Human activities such as bottom trawling, deep-sea mining, and oil drilling threaten the delicate ecosystems within submarine canyons. These activities can disrupt habitats and alter sediment flows, with potentially long-lasting consequences. Protecting submarine canyons. Given their ecological importance and geological significance, efforts are underway to protect submarine canyons through marine conservation initiatives. Establishing marine protected areas, MPAs, and regulating deep-sea activities are essential steps to preserve these underwater treasures for future generations. Conclusion. Submarine canyons, hidden beneath the ocean's surface, are among the most impressive and important geological features on Earth. Larger and deeper than their terrestrial counterparts, these canyons are carved by powerful underwater forces that have shaped the seafloor for millions of years. They serve as vital conduits for sediment, hotspots for marine biodiversity, and archives of Earth's geological history. As scientists continue to explore these underwater giants, they uncover not only the mysteries of the deep, but also the interconnectedness of Earth's systems. Submarine canyons remind us that the most awe-inspiring wonders of our planet are not always visible, and that the oceans hold countless secrets waiting to be revealed.